Okay, let's take a deeper look into frequencies and channels. Let's start talking about channels. So in this video, we're going to get a little more into frequencies and what those frequencies look like and how they apply to channels. So we're going to start talking about channels, and then we're going to take that and apply it to the difference between 2.4 gigahertz and a 5 gigahertz frequency. All right, I showed this diagram in my last video as well when we were talking about wavelengths and frequencies and the different ranges of it. So I'm not going to go in depth like I did last time into it, but there are some things that I want to draw out from this. This diagram right here ranges anywhere from the 50 hertz, which is the 50 cycles per second, to 1 megahertz, which is 1 million cycles per second. It has a 1 gigahertz, 1 billion cycles per second, all the way to the 30 exahertz, which is just something crazy. So this really shows the wide range of different frequencies, different electromagnetic frequencies that are out there. So, and we see that there's this band in here that we widely use for communication. So that's the low frequencies, the radio frequencies, the microwaves. We use this whole range for different communication. And as you can see here, their radio frequencies has actual radio. We've got some TV. We've got some broadcast that goes out there. We've got our Wi-Fi in there. We've got our microwave in there. So here's some of the devices within each one of those with each of those frequencies. Now, what they want to do is they want to limit usage of certain bands of frequencies within here. As an example, they don't want just anybody to be able to broadcast a TV program. So you've got to get a license to broadcast that out. Or they don't want just anybody to start broadcasting a radio frequency that's already assigned to somebody else. So you have to get a license for that. Or pilots in the sky that are talking to air traffic control. They don't want somebody to be broadcasting on that same frequency. So you've got to get a license for that. So you've got to get licenses to broadcast within these different ranges. Although there's some exceptions to it. They've taken some of these ranges within here, and it's kind of just little slivers within here, and they've created these bands that you can actually do your own thing in, that you don't need a license for it. You don't need a license to create certain equipment in it. So an example of that is the 9 megahertz range. So when phones started going cordless, I'm not talking about cellular, I'm talking about the landline phones, but they had corded or cordless phones. Those were operated in the 900 megahertz frequencies. And then they came out with the 2.4 gigahertz frequency because that's another range that they have that's open to people. Same thing with the 5 gigahertz. There's a band within 5 gigahertz frequency. And so that's why you see a lot of Wi-Fi that's operating at the 2.4 gigahertz frequency and the 5 gigahertz frequency. Now, other thing that I mentioned is these lower frequencies tend to travel further and go through obstacles better. So think of somebody who is driving down the road and they have their speakers blared and it's really loud. And what do you hear first? You hear the low frequencies because they travel further and they go through more obstacles. Versus the higher frequencies, you don't hear the mid-range or the highs until that car is closer, and sometimes you don't even hear the highs until they're really close to you. So those lower range travel further, and so the upper range, though, even though we can pack more data into it, it doesn't travel as far and gets hindered by certain obstacles. So they don't operate as well with transferring data from that perspective, but we can transfer more data. So there's some advantages to the low frequency and sending data through the low frequencies, and there's some advantages to the higher frequencies. But this is a cool chart that kind of gives you an example of all those different frequencies and what ranges are open. So the 2.4 gigahertz frequency is an actual range, a band that's open that you don't have to have licensed use it. And so that's one of those Wi-Fi networks that are used out there. And Wi-Fi is built into channels. So we've got channels. So here, let's say where this is channel 1, this is channel 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then in some countries, they have 12 and 13. And one country, I think, has 14. Maybe a couple countries have 14. So really, I'm not going to consider these too much in the next discussions, but you'll see that we have these channels that we operate in. So what are these channels? What do they do? So let's talk about why we need channels and how they operate. All right, so let's talk about channels. This is an access point right here, and it's going to be assigned to channels. So let's say it's assigned to channel 1. And this device then communicates to this access point on channel 1. Now we bring in another access point to this. And when we add this access point, we need to choose a different channel. It can't be the same frequency that this radio is communicating off of. So maybe we assign this to channel 2 for other devices to be able to connect to this, so that way you can keep your frequencies separate. Although we can't exactly assign 1 and 2 next to each other, and I'm going to explain why here in a second. So I've got here, let's say I want connectivity in this office, so I'm going to set up a access point in this, it looks like a office with a conference room in it. Here's another conference room, so I'm going to set up an access point there. Here's a conference room, so I want to set an access point there. Here's a office, so I want to make sure they have connectivity. Here's another office, so I want to make sure they have connectivity. People who are in the bathroom will probably get a signal from there, but I don't really care too much if it's a strong signal, so I think that's fine. So now I've got some access points into here. So then when we actually do the install of these devices, I'm going to set up the access point. Then we actually see what's called a heat map, the coverage area of these access points for the office. Now, this is not a fair representation because some of these walls are going to cut down on the signal, and so it's going to be altered a little bit. But for the most part, let's say I have an access point here right in the office, and then this is going to be my coverage area from that access point. Like I say, not including how the walls and how the different materials are going to interfere with it. Let's just say for now that is the coverage area. The access point that I have in here is going to have this coverage right here. Now what I need to do is I need to separate these different access points into different channels. I can't have them overlapping. So if this is 1 right here, then maybe I would assign 2 right here and maybe 3 right here, 4, 5. Okay, no problem. I don't see a problem at this point in time. But there is an issue. I'm driving home to a point, so let's take this to the next level and see what happens with these channels. When I talked about electromagnetic fields and being able to send data through it, I said that there's 2 ways we can send data. One of them is through amplitude modulation. We can change the amplitude. One of them is frequency modulation. We can change the frequency. Now we tend to actually get better data through the frequency modulation. That's why your AM stations, or one of the reasons why AM stations are better suited for like talk radio, and FM, frequency modulation, FM stations are better suited for radio, is because we can actually pack a little more data into frequency modulation. That is not the only reason, but for now, let's just use that as a framework. All right. So when I'm talking about Wi-Fi, we're doing frequency modulations. We're adjusting the frequency just a little bit to either represent a 0 or 1 or whatever data we're trying to represent. So for channel 1, it is operating at a 2.412 gigahertz per second, or gigahertz. That is a billion hertz per second. So we've got that frequency that we're operating at. Then we adjust it one way or another to represent those 1s and 0s, to represent the data that is being sent across it. So we actually need some of the frequency before it and some of the frequencies after it. We need a band. For this channel, we actually need a whole range, a spectrum of frequencies there to adjust to send this data across. And so that's what you're seeing by this chart right here. We have a channel, we've got a frequency, and then we've got the range within it that we need to be able to send data across it. Now, what's interesting about this is this range right here overlaps. It overlaps channel 2. It also overlaps channel 3. And if we look at channel 4, channel 4's range overlaps channel 1, and channel 5's range overlaps channel 1 as well. So it's not until channel 6 that we can actually use the next channel. And we do the same thing. The top of this range is 2448. So the next bottom of the range that we can use is channel 11. And channel 12, 13, and 14 isn't even available in some of our regions, in some of our countries. And so we really only have 3 channels to work with. So now let's go back and take a look at our heat map and see how we can lay things out. Here's another visual of that same effect here. So we have the 2.412 range right here. That's channel 1. It uses up a range here. And then channel 6 uses up this range right here. Channel 11 uses up this range right here. So it uses up these ranges, and we only really have 3 available. And if you're in certain countries, 12, 13, and 14 don't exist. So in those cases, any other combination you have only allows you to have 2 channels, which is probably why they brought in these extra channels here, is so that you can actually get a little more channels, a little more usable channels out of these. So we have a problem. There is a problem in the limited number of channels that we have. So now let's take a look at our heat map. If I assign channel 1 to here, and then I can't assign 2 to the next one because those would be overlapping. So instead, let me assign channel 6 to it. And then I am going to go to this one right here and assign channel 11 to it. I can assign channel 1 here because it's not overlapping this one right here. But right here now, I have a problem with this coverage area. I can't assign to a 1 because it overlaps with this one. I can't assign a 6 because it overlaps with this one. I can't assign a 11 because it overlaps with this one. So I'm not able to put the access point there. So this can be problematic on our networks. And that's one of the downfalls of the 2.4 gigahertz range, is that we're really limited on the bandwidth that we have, that we can work with. And one way to compensate for this is we'd have to lower the power that each one of these access points broadcasts. So there's a lot of kind of adjusting that I have to do to make this all work, and I have to do placements of all of these. So we're limited with the amount of channels we have, and we're also really limited, and it takes quite a bit of changing things around to get this all to work correctly. So it's a bit of an artwork to try to get this all to work correctly, especially when you're talking about the 2.4 gigahertz range. The 5 gigahertz range has a lot more options, and it's got different ways that we can open up the bands to send more information within each one of these channels. And there's a lot more configuration within the standards for 5 gigahertz. It opens up a lot of possibilities. So typically, we want to use 5 gigahertz over 2.4 gigahertz. The only downside with 5 gigahertz is it just doesn't, it can transfer more data, but it just doesn't travel as far, and it gets interrupted more with different obstacles. So it doesn't travel through walls as well, and so it can be more problematic in some cases. All right, so let's do a little comparison here between 2.4 gigahertz versus 5 gigahertz. 5 gigahertz has a higher data rate, and it's actually less susceptible to some interference. So there's less frequencies that will interfere with this frequency. However, it doesn't do as well with obstacles. So 2.4 gigahertz has a larger coverage area and is less susceptible to obstructions, things like walls, and it's a very crowded space, which means that there's a lot of devices that use that 2.4 gigahertz frequency. All right, there you have it. Frequencies and channels. So we started out taking a more in-depth look into frequencies and how when you're talking about frequency modulation, you're actually talking about not just a specific frequency that you're sending data across, but a range of frequencies that you modulate within there to send that data. And we call that a channel. That is a channel that can get opened up and to allow communication to happen. Now the problem is that the 2.4 gigahertz range has a lot of overlapping channels, making it very limited in what we can use 2.4 gigahertz Wi-Fi for. And so 5 gigahertz is really the ideal in many situations, although there's still a use case for 2.4 gigahertz when we're talking about those longer ranges or having to go through some certain obstructions. Thanks again for watching my video. If you liked it, could you hit that like button?